to see if this little setup is going to work for us to record lessons. So all I need is that triangle. Because once I know where I am on the circle, I can draw the reference triangle, which we did last year, oriented the way it sits in the plane, and that helps me get everything straight. Well, it's also good to think about what quadrant you're in when you're in that triangle. What quadrant are we in? Third quadrant. What's the significance of the quadrant in terms of what does that tell us? It tells us what? It's the? No, it's tangent and cotangent because it's reciprocal, right? And typically we only talk about the three, sine, cosine, and tangent, but because we're in a situation where we are to list all 6 of them, it's important that you remember that the reciprocal relationships follow the sign of the one they reciprocate. So when you reciprocate a relationship, you don't change the sign of it. Does that make sense? S-I-G-N. So does that help? So really all that matters is how you draw the triangle. And in this case, both your x and your y are negative, which tells you what about your trig? When I know the coordinates of my location, what does that tell me relative to the trig that I'm asked? Sine and cosine, right? And why does it make sense? And I know this is all should be very basic, but just to kind of get that part of your brain reawakened from last year, why does that make tangent positive? Okay, but you haven't answered the question. Because what is tangent? It's sine over cosine. Because tangent is a ratio of sine over cosine, it makes sense that if they're both negative, tangent will be positive, right? So when you do things right, all the pieces come together. Okay, does that take care of all the questions on that one? Okay. And if you have weak spots, resume recording. We are recording again. What was your question, Madison?
Okay, so the point was negative 3/5, negative 4/5.
Yes.
And with the thing like sine and cosix kind of thing, can you not just automatically tell from right there that that's your sine and cosine?
Yes, you can.
Points, and you don't even have to do well, I mean, you want to draw it out to see it, but that's basically.
No, I only drew the triangle out, and I wouldn't have drawn the triangle out to do this problem. But the point I'm making, because the most pervasive question about this item was, but we want angle T, so what does that have to do with the triangle? Because remember, it doesn't matter how you got there, and that, in other words, it doesn't matter what the angle is. It's where you ended up that decides what the ratios are. So that's why I drew the triangle, to make that point. But yes, so your sine is. And your cosine is, which would make your secant and your cosecant, and the only one you would have to do any computation for is your tangent, technically, but you already know the hypotenuse, right? So even if you didn't know the hypotenuse, you could do it by dividing sine by cosine or y by x, right? And do the arithmetic to get that. But we know that the hypotenuse is 1, and so that helps you with that as well. Y'all with me? Okay. Any other questions about anything from 1 through 10? All right. Now, I need you to keep those 2 sheets that I got Fran to hand to you earlier handy, because we'll figure out what we need as we go from that sheet. In particular, what you want to pay attention to is the sheet that has all the geometric shapes, 3D and 2D, and the lower right corner of that page, formulas from trigonometry. In particular, and everything up to that, I mean, literally all we needed off that page, and I was going to cut this out and put all the trig stuff on one page when the possessed copier had other plans, is the Pythagorean identities. The Pythagorean identities you're going to need to know. And if you'll look, I believe all 4 of those are on your, all 3 of those are on your unit circle. Okay? And those will be, and the ones that are on the unit circle are the ones that primarily come up again and again and again in calculus. And they don't come up every day, but if trig comes up, those are the ones that you're going to need to know. Now, for what we're going to do today, because we're going to go through some identities, proving some identities, you'll need the ones, and you'll see on the other sheet where it says formulas from trigonometry continued. You probably won't need the odd even identities. You will probably need the sum and difference identities and the double angle identities, and maybe the power reducing and half angle. Okay? So you'll want to keep these sheets that I was going to make into one sheet for you. You'll want to keep these for later reference, just because even if we don't use them in this class, you might at some point need them. So if you walk into a math or engineering class and they say you need to know all your trig identities by tomorrow, this is your place to come to, okay? So, and by all of them, you might want to ask if that includes all those that I said you won't necessarily need. All right, to show you how this works, somebody have an assignment sheet? No, I got one. I was thinking I had run out, but I didn't. You're supposed to do 1 and then 5 through 15 odds, and then 25, 29, and 59. It's a fairly short list of problems because these are fairly work intensive, and sometimes not just fairly work intensive, but actually work intensive. And you'll see what I'm talking about when we get started. So we're going to do some even numbered problems as examples, and especially since we got a late start with the fire drill and whatnot this morning, we'll probably have at least the rest of today and tomorrow to work on this. I don't want to work on it any longer than we need to because I'm ready to get into the textbook and get into the calculus. But that kind of just depends on where we are. So let's start with number 2. Verify the identity actually means prove the identity. And what we're looking at on that one, so you're definitely going to need some paper for note taking. Not going to have, unless you want to take it on the back of these reference sheets if you're a slob. Did I just call somebody a slob? So we are to prove that cosine x, cosecant x, oops, and I put cosine. Erase that. Try again. Equals cotangent x. Now, the general rule of thumb when you are proving a trig identity is to read what you're given and focus on the ugly side, because you want to look at the ugly side to see what sort of cleaning up you can do. Okay? All right. So another strategy to know about is that you're looking for anything that's not sine or cosine, because you want to turn everything, when you don't know what else to do, when nothing else jumps out at you. And when I say mean jumps out at you, as you get to know these identities by looking for them on the sheet, when you look at this, if you don't see something that jumps out at you as an identity, then you're going to, your second choice strategy is to turn everything into sines and cosines, okay? Well, cosine x is already cosine x, so we're going to keep that. And we're going to start on the left side because it's uglier than the right side in that we have 2 things on the left and 1 thing on the right, okay? So cosine's already cosine, so we're going to keep it. But how can we rewrite cosecant? 1 over sine x. So I'm going to rewrite that as 1 over sine x. And then I'm going to keep working my way down, focusing on this left side. And then if I multiply that together, I get cosine x over sine x, don't I? But what is cosine x over sine x? Didn't y'all just tell me that tangent is sine over cosine?
Yeah.
So this would be cotangent x. Well, as soon as I keep working on the left until I find the right, I keep working. Well, do you notice what just happened?
Yes.
I have cotangent x equals cotangent x. So in other words, I've gotten the left side to equal the right side. I have verified the identity. Can you not sit in that far corner? How about that? That's not a good spot to sit for the, and I didn't actually have a desk there. If you'll recall, there was one up in the corner out of the way. So y'all need to sit where you can see. There's plenty of room to sit where you can see. All right. Any questions about that one? That's kind of how it works. No?
So some just won't work.
Oh no. If it says verify the identity, it will work. Now what will happen is that you will do half a page of work and it will get uglier and uglier. That's another little tip for you. If, as you're trying to clean up an identity to prove the identity, things just keep getting uglier and uglier the more you do, you should probably put a big X through that and start some other way of dealing with the problem. Okay, go back and think about it again. Because it should not get nastier. It should, even, and sometimes, and this takes practice and sophistication, and we're not going to get too far into this field because of the fact that you don't have to go that far in calculus. You just need to have the reflex in your brain that if this is what I got for my answer, then it matches this multiple choice answer because sine squared plus cosine squared equals 1. Because some of you be like, well, I got sine squared plus cosine squared, and the back of the book says the answer is 1. How is that possible? Well, it's an identity. That is 1. Okay? Now that comes from the fact, and I think I actually explored this with at least one of the honors pre-cal classes last year. If you take the coordinates of any point on the unit circle, square the x, square the y, and add it together, guess what you get? 1. All the way around the unit circle. Okay? So that's a fundamental fact, and that's where these identities come from. They have been proved as fact. Okay? So you've got to be able to interpret your answer that way. So let's do number 2. And please feel, I'm sorry, number 4. I meant the second even one. That's what my tired brain meant. Cotangent. Okay, come on, we can write. Cotangent negative x times sine x equals negative cosine x. All right? Obviously, of these two sides, which would you refer to as the ugly side? The left side. All right? So we're going to focus on the left side. And if you don't see an identity jumping out at you, you should start working to rename what you see. And you don't know identities well enough to be looking for them, so that's kind of a bit of a disadvantage for you here. But that's why you have these 2 sheets. If you will look at the upper left corner of the second sheet where it says the trig formulas continued, the odd even identities, yeah, y'all don't need these stuck in your binders. These need to be like free floating around your desk today while you work with them. You see the odd even identities. So when you see a negative inside the parentheses, go there and figure out a way to write it without that negative inside the parentheses. So what is the cotangent of negative x? Negative cotangent x, yes? Okay. So we're going to rewrite that step as negative cotangent x sine x. And I'm getting a little bit distracted because a few of you seem kind of not with me. You better be with me today because I'm not reteaching this to you later. This is your one shot to get trig identities down, and you're going to need them later if you're going to be successful in this class. All right, so I'm going to let that negative cosine x just kind of sit over there for a while and see if I can turn the left side into negative cosine x. Okay, what's my next strategy? That's right, we're going to rewrite cotangent in terms of sine and cosine. And what is it? Cosine x over sine x times sine x to complete that ugly side I'm working on, right? Are you with me? Okay. And now what happens? The signs cancel, and what am I left with? Negative cosine x. Why is that great news? Because that's the right side. So negative cosine x equals negative cosine x, and my work here is done. Yeah, I actually liked these when I was in school. Most students hate them, but to me they're just puzzles, you know? So if you like puzzles, you should like this. And you may not like it instantly or immediately or initially, but hopefully with some practice you will. While we're on a roll, let's go to number 6. And we have cotangent x, secant x, sine x equals 1. Do what? 6.
Quick question.
Okay.
Do you have to put like the little dot to times it?
No, I just do that for emphasis because it kind of can run all together when you're writing it by hand.
Okay.
Good question. All right. Clearly, which would be the ugly side here? The left. And typically, that's where the ugliness happens, is on the left, and that's not unusual in general either in textbooks. And I guess because most students find this difficult, they try to do that little bit to help you out. Usually you're going to start with the left, and we'll upgrade to some more difficult ones in a minute if y'all are getting bored. Suggestions? Okay, that's right. We're going to rewrite cotangent and secant in terms of sine and cosine. What is cotangent? Cosine x over sine x. And what's secant? 1 over cosine x. That sounded kind of mumbled or something over there, like there was some confusion. And then we have times sine x. And we go ahead and put that over 1 for emphasis. What's going to happen here? The cosines cancel, the sines cancel, and we get 1 equals 1. And our work here is done. Get it?
Yeah.
What else would there be? Well, there was nothing to do. And that different things will work on different ones depending on what you're getting, like what the initial setup is. Hey. No, what I said was that the Pythagorean are, those eventually and fairly quickly need to find a home in your head. Now, until we actually talk about trig in the context of calculus, don't panic and think, oh my God, I haven't learned those yet. Because it's not like I'm going to throw a quiz at you randomly to see if you've learned them. Because in my mind, you actually learn things by using them. And when we get to the point where we're doing trig stuff, I'll remind you of it. But what I said was that the ones that you're really, really going to need, and I know you're going to need between now and the AP exam, and on the AP exam, are on your unit circle reference. So you've got some identities down the right side over there. You hadn't paid them much attention just because we didn't get to them last year and we haven't used them much. But today's where you're finding out why they matter. Okay? This is going to be the other problem with my little setup. Hello. There you go. Okay. Let's pick another one. Let's see if we can up the ante a little bit. Let's go to let's jump all the way to number 8. And believe it or not, just by taking one more step down the page, this is upping the ante. Cosecant x minus cosecant x times cosine squared x equals sine x. Trick question. Psych. Which one's the ugly side? The left. The left is clearly uglier, right? Okay, so let's focus on the left side. Anybody notice anything here? There is a square. That is something to notice. But the other thing, and I haven't mentioned this, but anything you know that is algebraically legal, you can and probably should do when you're working on identities. Do you see anything algebraically that we could do? You can subtract what? Okay, why can I not do cosecant minus cosecant? Because one of them is multiplying cosine squared, right? Okay? That's like if you had 2 minus 2x. You don't do 2 minus 2 and then say, well, my answer is x. Do you? No. So we're not going to do that here. Yes, ma'am. Why would you do that? I will tell you there's no reason to involve the other side here. This frightens me just a wee tad that not one soul has uttered the magic words. Okay. Excuse me?
Factor out.
Now, the fact that you said distribute told me you were going to the right part of your brain, but Mr. Gallahorn has saved the day. We can factor out a cosecant x. You should always look for things they have in common to take that out. So let's do that now. So we're going to take out cosecant x. And when I take cosecant x out of cosecant x, what's left? 1. When I take cosecant x out of cosecant x, cosine squared x, what's left? Cosine squared x. Right? Correct? Okay. We're on the left side, so I don't want to confuse you. We're not even looking at the right side, because the object of the game here is what? To get the left side to be sine x, right?
Can you explain that whole thing? I don't think it's
What, the whole point of what we're doing?
No, like, yeah, that stuff right there.
Like what I just said, or like
Yeah.
what we just did
Can
on
you
this
just
one?
repeat what you said?
Okay, what I said was that when you're doing, and this won't work on all of them, and I'll show you one where that doesn't work, and then we'll go from there. Sometimes, okay, on the ones we've done so far, there's an obvious ugly side and an obvious basic side, right? when that's the case, your strategy will be to clean up the ugly side and keep working on it and polishing it and chipping away at it until nothing is left but the right side, so that it matches. Just like back in Algebra 1, and I just did this in my Algebra 1 class last week. I gave them like 3 equations, and for each one it said, no, this was in my pre-cal class actually. We were reviewing some Algebra 1 stuff. But they were given some equations, and they were told to show that the statement was true. Well, how do you show an equation is true? Right, you work on both sides. You simplify each side. You do to both sides whatever you have to until, as Becca said, the sides are equal, right? Well, that's exactly what we're doing here. If you look back at all of them, we stopped when we got the same thing on both sides, and that's the object of the game here. Now, I said this won't always work, and that will be where you have 2 ugly sides, and you have to do different things to the ugly side, both ugly sides, until you get something that's equal on both sides. And it's kind of, and the way that'll work is I still recommend that you start with the left side and work on it until you can't go any further. Like there's literally no other trig that you can apply, and then go and start the same process on the right. And now you know what your goal is. It's to get whatever's over there on the other side. Does that make sense? Okay. All right, so we good so far on this one? Now, I'm going to take a little side step to a fresh screen because this is probably the most important thing you can take away from today as far as what you're going to need for calculus. All right, let's talk about the identity sine squared x plus cosine squared x equals 1. Now, I think we talked about this last year, but I want to refresh your memory. Yes?
Are we doing this as like a separate?
Well, you can kind of do it over beside the problem we're working on, and you're going to probably want to put a box around this because this is hugely important that you get to the point where you recognize what we just got in parentheses on this problem we're working on, okay? All right, the first thing I want to remind you of is that notation, written sine squared x, really means sine x squared, and that cosine squared x means cosine x squared. It's just a method of notation that's much more compact and efficient, but it's understood that that's what that means. Even though in some of your minds you probably aren't comfortable enough with trig yet to have that clear, make sure you're clear on that, okay? So that's one side note about it. All right, but let's go back to the main identity itself. Sorry about that. And focus on that. If I wanted to solve that identity for sine squared, what would I do? I would subtract cosine squared. So it's like you get variations of this identity built in for free if you understand what's about to happen. So if I subtract cosine squared from both sides, I get 1 minus cosine squared x. Right? Okay? No? Yes? Okay. And then if I wanted to solve it for cosine squared, what would I get? Okay, so I would subtract sine x now. So cosine squared x equals 1 minus sine squared x. Now, a lot of times they'll show up in all these variations, just like the 3 that we've written here, where it's the original identity and then these 2 with one term pulled to the other side. But then sometimes it'll be cosine squared x minus 1, and then you'll recognize that as negative sine squared x. So that's what you really want to get adept with sine squared plus cosine squared identity. You've got to know that one, okay? So remember that little ditty we did there. And the way to assimilate it is that as you work on this assignment, watch for any expression that involves 1 and either sine squared or cosine squared. And they have to be in different signs for this to apply. If the signs are the same, then it's not gonna do what you need it to do. All right. So let's come back to our identity. Based on what we just said, does anybody see anything here? How can I rewrite this left side now? Cosecant x
minus sine squared x. No,
times
sine squared x.
You with me? Because we've just renamed 1 minus cosine squared x as sine squared x because that's what it's equal to because of that identity. Okay? So the identities won't be like, oh, well, I'm going to replace this with the right side because this left side looks just like that identity. Sometimes you have to rearrange them to use them, especially the Pythagorean ones. Okay? All right. So that being said, now that we've gotten this far, any other thoughts? And we want sine x, so I wouldn't mess with the sine squared x because it's got one too many signs, right? That's right. The cosecant x we can rewrite as 1 over sine x. So now I have 1 over sine x times sine squared x over 1. And then that square cancels away with that sign on the bottom. And we are left with sine x. Why does that make us happy? Because we're done. That is the right side. Got it? So, yes? Question? Huh?
So they're kind of cool. It's like,
Yeah, they're kind of fun. Until I just throw them at you and you start doing you do an entire page of work and then somebody's like, Madison, what are you doing? Because I did that in like 3 steps. Then you're like ball it up and say, never mind, this is not fun. Okay. But we love you and we'll enjoy watching you experience that. All right, let's see where we want to go next. Let's jump down to 12. And then we'll do 26 just for you, Matt. And then I will let the whole class know that it was on your behalf, and if it's not fun, we'll blame you.
Okay.
All right. I know you don't. If I thought you did, I wouldn't say that to you. Okay, me and this board are fighting right now. Maybe I need to clean it. Tan theta plus cotangent theta equals secant theta cosecant theta. Any thoughts on this one?
Break down tan and cotangent removed.
I'm going to have to change the settings on my computer. That's why we're doing this as a test run, so I can figure out all the little technological issues I didn't anticipate. Maybe I will hire a serious student, not hire, but assign a serious. You are not a serious student. I don't know what you. I will put someone I can trust, which would probably imply that it would be a female, probably Fran, because she's not going to play around with this, and have her just randomly touch the mouse so that doesn't happen again. Because we have paused our recording. Okay, no, it didn't pause. Cool. Because we caught it fast enough. All right, so, did I copy it right?
Yeah.
Okay, cool. Tell me what you think. If we're using the logic of the original set of questions I gave you to ask yourself, what question should you be asking yourself right now? Which side is ugly? Right? Well, let's start working on the left and see what we can do. Okay? Or do you want to? Talk to me. What do you think?
Yeah, let's do that.
they're all like,
Okay. That was what I was hoping someone would notice, but I wasn't sure whether or not I should rely on that possibility. Being that you recognized it. Is when you write this down, it should occur to you, and I know that you don't know the reciprocal relationships yet, but I will give you a hint here that in your simplistic way of looking at things, you might say the left looks easier, but actually when you're adding sign things, it's harder to deal with than when you're multiplying sign things. Because of the fact that when you have trig things, when you have trig things being multiplied and you rename them in terms of sines and cosines, nice things tend to happen. So let's work on the right side first just to see if we can make, because neither one of these sides is terribly pretty or simple, right? Okay, but so we'll start on the right on this one for that reason. And that's the thing, so some of you are going to panic and say, well, how am I supposed to know that? Well, you just have to know how to think when you're reading problems, okay? What is secant? 1 over cosine. Remember, the cos don't go together. And what is cosecant? 1 over sine. Yes? Did that do us any good? No. So, but that was worth looking at, okay? So now you've got 2 versions of the right side, and the reason that might be helpful is that when you start working on the left side, if you didn't do what we just did, we might really see the 1 over cosine times 1 over sine faster than we would see what's there. Are you with me? Some sign of life would be nice. Okay. Other than the fact that I see your chest moving as you breathe. And I've actually had students before where I'm like, are you breathing? Especially during tests, especially during calculus tests. And then when you see me chuckle while you're taking a test, it's because I see that you're not breathing. And I will remind you to breathe. Okay. What is tangent?
Sine over cosine.
Sine over cosine. Sine theta over cosine theta plus, and cotangent is? cosine theta over sine theta. All right, now when we get into ones like this, and this is the beautiful thing about teaching proving identities, and it's one of the reasons that proving identities is taught as a lesson, is that it forces you to recognize in abstract fundamental things that you know how to do in terms of solving equations and combining terms and that sort of thing. All right, what we have here is two, I think you would probably agree, fairly unattractive fractions, right? Okay, well, how do you add fractions? Common denominator. Okay, so the first fraction, what would the common denominator here be? Cosine sine. All right, so I'm going to put a big long bar and put cosine sine as my denominator. Yes? To get the common denominator for the first term, what would I have to multiply by? Sine over sine, right?
Yeah.
So what would that give me on the top?
Sine squared.
Sine squared theta. Plus, so far so good? Okay. How about the other guy? I'd have to multiply by cosine theta over cosine theta to get the common denominator, which would give me cosine squared theta. Ding, ding, ding. There's something you should notice.
Sine and cosine.
The numerator is just 1. You with me?
Wait, say that again?
What is sine squared plus cosine squared?
Oh.
1. So it's 1 over cosine theta sine theta. So it's the same thing. Why? Because how do you multiply fractions? You multiply the tops and the bottoms, right? So my right side over here is 1 over cosine theta sine theta. Right? So we've gotten the right and the left to equal the same thing. And that means we're done. Check. On to the next one. Got it? Simple enough? Now, as per Mr. Gallahorn's request, we're going to jump on down and do as our final example, before I throw it at you and let you try it, number 26. And I don't mean try number 26, I mean do the assignment, because I feel like you will have been fairly well equipped at that point. So we have sine t over tan t plus cosine t over cotangent t equals sine t plus cosine t. Now, I told you a minute ago that if you have a choice between dealing with added things or multiplied things, go with the multiplied things, but what's the bad news here? It's all addition. Okay? But now when you look at the left versus the right, talk to me in terms of anything and all you can do. Which side has absolutely nothing I can do to it? The right. Because sine and cosine are already there, right? And it's just sine plus cosine, which tells me nothing, right? Okay, so that means we got to go to work on the left side.
Can you break apart the denominators and then?
Yes, you can do that. If I understand what you mean by break apart. Tell me specifically.
Break it into, it would be sine over sine over cosine, and then you would do.
Okay, you can either do it as sine over sine over cosine, which is why I was asking. I wanted you to say it because I wanted to hear where you were going with that. Let me show you another way that's cleaner, but it's doing the same thing. Okay. If I take that first term and rewrite it, I could rewrite it as sine t times 1 over tangent, couldn't I?
Yeah. Why not?
And that's one way to break it apart, as Becca was talking about. It's a good way to think about it, because when things are all pushed together and you've got to pull it apart to get it to be something else, that's kind of the way you need to be thinking. All right? So then we're going to do the same thing to the second guy. So this is going to be cosine t times 1 over cotangent t, right? Or what was on the bottom of that one? Cotangent t. Oh, I was looking at it wrong. Okay, so far so good? But what is 1 over tangent? Cotangent, right? So this is sine t times, and now this is normally in identities when in doubt you should write every single step, but I'm going to try this, and then if anybody freaks out I'll show you what step we skipped. If 1 over tangent is cotangent, how can I write that in terms of sine and cosine? Cosine t over sine t. Why is that a good way to write that?
Because then you can cancel.
The signs are gone. Boop. Good news? All right, same idea here. Now we have cosine t, and what is 1 over cotangent? Tangent, which is sine over cosine. Why is that also good news? Same reason. And Mackie's right. Not only did beautiful things happen there, but what was left was exactly what I wanted it to be, right? Because I can rewrite the order of things being added. So I get sine t plus cosine t equals sine t plus cosine t. Check. And done.
Bring like the right side all the way down. Like,
You can do what I've been doing, okay? As long as your work is organized. Now, that's a very good question, and you all need to listen because one of the issues I have with pre-cal students is how they put things on a page and like where you put things, okay? If you're going to take the approach I did here, and I recommend it just because it's a lot less writing, in a perfect world, you would keep writing the right side, but that gets old fast, especially on a long trig identity proof, okay? So if you do what I did, where notice that I kept all the left side stuff completely under the left side and worked my way down, and then closed it with a final statement that they were equal, that's fine. Because it's evident, if you, and especially if you keep putting the equals on the right side of your statement, which I kind of wasn't doing, okay? Any other questions? Thanks, Franny. Franny to the rescue. I think we're going to have to get her a cape before it's over.
What happened to the one? What happened to like?
It was like my left ear was hearing Haney and my right ear was hearing you, and I heard nothing. Go ahead.
What happened to like the 1 over tangent and 1 over cotangent?
Okay, let's go back to that because I said that I technically ought to write another step, but I'm eager to throw this at y'all and see how you do with it. All right, the step I didn't write in here is that, and I'll go back and write that now and interject that for anybody that wants it. If you're good with what we had and you don't think you need it, don't write it. All right, so we had sine t, and then we rewrote what 1 over tangent was in terms of sine and cosine, but an intermediate step you could do is to write cotangent t there, right? Because 1 over tangent is cotangent, which is why we were allowed to write it as cosine over sine. Okay, and then plus, and I'm running out of space because I'm writing too big. All right, and then what would that give me for the other one? Cosine t times what? What's 1 over cotangent? Tangent t. So that's the step I didn't write. And that's why the steps become so important. Because sometimes, and probably being new at it, y'all aren't going to think to do 2 steps at once. Because you're just going to go like baby steps, which is exactly what you need to do. And that's a good proof. Yes?
If we can, like, I just started on number 1, like, if we can break it apart and get it to, like, sine over cosine and the other side is tan, should we keep it as tan, or does it matter if we, like, leave it as the more expanded form? Do you care?
Actually, in the ideal way to write trig is always in the most compressed form.
Okay.
So when if you get the left side to be sine over cosine, which is the next to the last step, then in your mind you should say, well, that's tangent. So write tangent and then say tangent equals tangent. You're done.
Okay.
Marquise, did you get your question answered and all that, or did you have a separate question?
Oh no, I was just talking about when you said something about making her quick. I was like, I'll make it.
I said cape.
Oh.
Have y'all seen